In this video, we're looking at product induction. So similar to summation induction, where that was plussing, this is timesing. And we use the symbol that looks like a very big pi instead of the sigma symbol for this one. Apart from that, it's pretty much the same concept. Now, the proof we're going to do in this video looks like this, and I will do it straight away with the product notation to keep the length down, but this in red is what the statement would mean without the product notation. Do note we're starting at 2, which is a little bit different than we might be used to with induction. Okay, so start out this by saying let Pn be that statement, and then repeat the statement. Now, normally induction starts with a P1 step, but our base case here is actually going to be P2, because we're starting at 2. So on the left-hand side, we've got I equals 2 to 2 of 1 take 1 over I, which is just going to give us 1 take a half, which is a half. On the right-hand side, we're going to get 1 over, and in our case, n is 2. So they match. Therefore, P1 is true. Okay, so that should say P2 is true. Okay, so we're going to assume PK is true. So that's what we'll do in this step. So PK, assume that the product of I equals 2 up to K of 1 take 1 over I equals 1 over K. We'll call that star for some K in Z plus, really specifically with K greater than 2. Technically, if I've said K is greater than 2, I don't really need the plus there. Okay, so we're going to do PK plus 1. Okay, so on the left-hand side, we will have I equals 2 up to K plus 1 of 1 take 1 over I. I'll work on that in a sec, but our want to show, or in other words, our right-hand side here, will be 1 over K plus 1. So remember, with this step, you're taking this little bit here, you're just having it as K plus 1 instead of K. That's always what you do. All right, so let's split up our product into 2 pieces. So this is going to split up into 2 up to K, and then times by the last term, so just that K plus 1th bit. There we go. So really importantly, if you're used to some induction, you might be tempted to put a plus in the middle, but we're in multiplication land now. So let's use star on this. So this little bit here will literally just become 1 over K. And then this one here is just 1 take 1 over K plus 1. So this product here is just the 1 term. It's the K plus 1th term. All right, and then we're going to say from star. Okay. So this just becomes, if we FOIL it in, so that first term is 1 over K, and then that last term is 1 over K bracket K plus 1. Alrighty. Now, generally what we'll do is we like to have a common denominator when we have fractions. So the same thing on the bottom of both ones. I'm going to do something called cross-multiplying on this. And that means that for this one, I'm going to be timesing it by K plus 1 over K plus 1, just like that. Now, technically, to do full cross-multiplication, you would also do this one by K over K, and I would also pull the K over K there. But as you'll see in a second, we won't need it. All I'm after is the same thing on the bottom of both fractions. This should achieve it. Okay, so K plus 1 is on the top of that first fraction, and it looks like that. And for the next fraction, that doesn't change. Now that these fractions do have the same thing on the bottom, I can just smush them all together into one big fraction. So we're going to have K plus 1 take 1 there. Then what we're left with on the top is just K. So that's K over K, lots of K plus 1. The K's will cancel. So they'll cancel off just like that. And then that's brilliant news because that actually gives us what we want. What you're left with on the top is just 1 after the k's have cancelled off, and k plus 1 on the bottom. This is the exact same as our want to show up here, which is brilliant news for us. So we can finish off our induction proof. Therefore, pk plus 1 is true. And therefore, by induction, we have that the product of I equals 2 up to n of 1 take 1 over I is just the same thing as a 1 over n for all n in Z with n greater than 2. I might just do that with a little comma. N greater than 2. Done.